Today you guys are going to learn how to multiply radical expressions. Tomorrow we'll do division. So see this worksheet? It's 2 days. We've got 2 days of work here. We're not going to do the whole thing. Okay? All right, I would like to review some simple rules. All right, if I give you this problem, what is this answer? What did you do?
Added.
If bases are the same, you keep the base the same and you add the exponents, right? Okay, now, what if I give you this problem? Okay, do you guys remember how to convert this x, square root of x, into a this is the radical, this is the radicand, and the index is a 2. Good. Do you know how to convert this to a rational exponent? It'd be x to the 1/2 power. Did you learn that?
Yeah.
Okay, good.
I need a refresher.
You just need a refresher. Where does the 1 come from? Well, first of all, where the base is x. This is your exponent, that's the numerator, and the 2 is your index. Now, can you convert this for me?
X 3 2.
Mm-hmm. Now, look at this rule right here. If bases were the same, we kept the base the same and we added the exponents, right?
So you just add 1 out of 3.
Yep, you got it. So our base is the same?
X squared.
So what would it be? Can you add 1/2 and 3/2?
Yeah.
What do you get?
4.
Good. And what's another name for 4/2?
2.
So that's that answer. So this question simplifies to be that. How did I do it? I rewrote it as a rational exponent, and then I used this rule. All right, so I want you to look at this first example right here. Right here. First of all, can you rewrite, this is red, the 4th root of 7. Can you rewrite that?
Yeah.
What would it be? 7 to the what power?
1/4.
Good job. 7 to the 1/4. That's perfect. Yes. Can you slide this down?
Yeah.
Okay. How about the 5th root of 7? How would you write that?
That's the 1/5.
Very good. Now, our base is the same. What would you do now?
Add
You add what?
1/4 plus 1/5.
Mm-hmm. Does anyone know what 1/4 and 1/5? What's the common denominator?
20.
It's 20. You guys are good.
20.
And you got it.
Wait, what?
20 is your common denominator. Or I'll write it here, slower. 1/4 plus 1/5. Your common denominator is 20. Now, 4 times what gives you 20? 5, so you multiply this by 5. And then 5 times 4 is 20, so you multiply that by 4. So now when you're adding fractions, as long as the denominator is the same, you add the numerator. 5 plus 4 is 9. So this is what you got for an answer. Now, the rule of thumb in math is, if a question is given to you in radical form, technically you need to answer it in radical form. Would you be able, this is called rational, because rational form, it's a rational exponent. Can anyone translate this? Remember, math is a language. Can you translate this with a radical? So here's your radical. What does this look like with a radical?
7, and then the outside is
20
20
squared.
and the inside is a 9.
Okay, wait, so I heard
7 goes under.
7 goes under,
x to the 9th power, and then it's to the 20th one off.
Perfect. This is your best answer. Okay? I want you to do, right now, number 2.
Can you go back to that final answer?
Yeah. Actually, no, I don't want you to do that one. I wanted you to do neither one of these yet. Hang on.
Agreed?
No, we're gonna do, no, here's another row. I'm gonna do 2. Sorry, guys. I'm gonna do 2 with you guys. I'll do the negative 1 in a second. Can you do this problem?
What do you mean?
Yeah.
You can? What would you do? How do you rewrite this?
6.
Okay, can you read that rule to me? Let's go back to this
You have to
rule.
have the same basis.
If bases are the same, if bases are the same, if the bases are the same, you keep the base the same and you add the exponent. Well, if the bases are the same, you do that. If then, are these bases the same?
No.
No.
No. Can't do this one.
Oh. What's that mean?
Not possible?
Wait,
In P.
how come you can't do it?
It says
Because
multiply if possible. Why can't you do this one? Someone else say it.
Which one?
Bases are the
The
same.
bases are not the same.
And the denominators.
Now, if this were a 2, or if this were a 6, then I could do this problem. Is everyone okay with this?
Yeah.
All right, now I want you to look at this problem right here. These bases are not the same, but I can do this problem. Why can I do this problem?
Yeah, the
Because
same
their
problem.
indexes are the same.
Yeah.
Now, I want you to see this problem written out. 4th root of 9. Can anyone break 9 up to the smallest factors?
3 and
3.
3.
3 times 3. How about the 4th root of 27? Can you break 27 up? What is it?
9 and 3.
9 and 3, or 3, 3, 3, right? Now, here's another thing you should know. If the indexes are the same, not talking about the bases, if the indexes are the same and you're multiplying, what you can do is you're looking for how many of a kind.
4.
This is the boss here. This tells you 4 of a kind. You can take from, if you're multiplying, as long as both bases are the same, I'm sorry, indexes are the same. If both indexes are the same, you can make 4 of a kind. Look at that, there's 4 3s right there. You can steal from this one to get 4 of a kind. So how many sets of 3s do we have? We have 1 set of 3, so that 3 comes out. Is there anything that's mismatched?
Is there another way you can do this problem?
This is the easiest way to do this one. This is the easiest way to do this problem. Or what you could do is multiply 9 times 27, but you're gonna get a bigger number, and then eventually you have to break it up anyway.
Yeah, that's what I'm using.
That's okay. He wants to multiply 9 times 27. I'm gonna show you his thought process. He's saying, hey, can we multiply 9 times 27? Yeah, what you're gonna do though, is to me, when you go that route, you're making more work for yourself. Because ultimately, you have to take 243, which is 9 times 27, and you gotta break it down. So what I would do is I would take the number 243, and I would say, okay, what times what? I have to think more doing it this way. I can break up 9 a lot easier and 27 a lot easier than it takes me to do 243. Does that make sense? So I don't care which way you do it. If you want to multiply these two together first and then break it up, but to me, it's simpler just to break it up right here and look for 4 of a kind. Now, we took these 3's out. There's four 3's that come out. What does not have something to partner up with? This little 3 right here. So we keep it underneath the radical. Okay? I want you to do 11 right now. It says the cube root of 4 and the cube root of 16. If the indexes are the same, if they're the same, can you do the problem?
Yes.
Yes. How do you break up 4?
2 and
2 times 2. How do you break up 16?
4.
2 times 2 times 2 times 2. Now, how many of a kind are we looking for? 3. Can I take from this this one right here? This radical?
Yeah.
Yes, because they're both the same. So we could actually, what you could think of it another way, is you're putting it all under one umbrella. 1, 2, 3, 4, 5, 6 twos. Does that help you?
Yeah.
Okay, good. Now, how many of a kind are we looking for?
3.
3.
So there's 2
We have
groups.
2, yep, you got it. So what is 2 times 2?
4.
So this answer simplifies to be 4. Let's go back to 10. Let's do
Why is it
10.
simplified?
Huh? Say it again?
Why would it simplify?
Because it's just like,
Because this, you have 3 twos, and then you have another 3 twos.
Yeah.
So this 2 comes out, and this 2 comes out. 2 times 2 is 4.
Oh, okay.
Okay, try number 10. Let's go backwards. It says, what are we doing here? Cube root, 4th root. What's the index?
the square root.
Square root. How do you break up 8?
2 and 4.
3 twos. How do you break up 32?
2 and 16.
5 twos, you got it.
How do you get that?
How do you get what? Tell me.
Like, how do you like know it's 5?
Because I've been doing this for 25 years. And after doing it for 25 years, this is how I started off doing it. I do a factor tree. I do 32 times 16 is 32. And then I do 2 times 8. And then I do 2 times 4. And then I do 2 times 2. So 32 is 5 twos.
Yeah.
The more you do practice, the quicker you'll get at it. All right, how many of a kind am I searching for?
2.
Okay, so count with me. There's 1, 2, 3, 4. So I'm multiplying 2 times 2 times 2 times 2. What do you get? 16. Good job. See these 2 twos? That's that 2. These 2 twos, that's that 2. These 2 twos, that's that 2.
Oh, it's a square.
2 times 2, because it's square root, yes. Now, what if I would have said 4, what if these were both 4s? What if these were the 4th root? What if I had a 4th root here? You would have a 2, 1 2 would come out, but then 3 would stay underneath. Because there's 1 2, there would be 4. Oh wait,
It would be
1
2
2
groups of
3
4.
4, 1 2 3 4. So it'd be 4. The answer would be 4, yes. It'd come out clean. Now, sometimes it does help to do, what is your name again? I'm sorry.
Mine?
Yeah.
Oh,
D'Angelo. You know how he wanted to multiply these 2? You can do that. Let's try that with this one. These are both cube root. So what is 9 times negative 81?
Negative 729.
Is it?
Oh, is it?
calculator, 9 times 81 is 729. So that's what his thought process, he would multiply them together. What kind of 729 would this be? A negative. Now I want you to think of this as -1 times 729. Okay? Let's deal with this 729. Can you break, we're looking for 3 of a kind. What does 720, can you give me 3 numbers that multiply to give you 729? Anyone know?
You can just take the third root of it.
What is it?
It's 9.
It's 9. 9 times 9 times 9 is 729. And so is, and -1 times -1 times -1 is -1. So do you see 3 sets of something? You see
Yeah.
3 sets of -1
Yeah.
and 3 sets of 9. What do you think the answer is here?
Negative.
You got it, -9. Okay, check out number 13.
It's not
Can
possible.
you, oh, good job. Why, I heard it's not possible. Why is it not possible?
The index is the same.
Good job. 8, this is 8 to the 1/4 power times 32 to the 1/3 power. These bases are not the same. Not possible. Can't do this one. How about 14?
Yeah.
What's -5 times 5?
Negative.
Can you take the square root of a negative number?
Not
It's
possible.
gotta be I though.
Yeah, we're gonna pretend like you can't do it right now.
Sweet.
Not possible. And let's do this one. What is, are these indexes the same? Yes. We can multiply these 2 numbers together. What's -5 times -25? 125. And what is 125? It's 5 times 5 times 5. Do we have 3 sets of something?
Yeah, it's just 5.
The answer's 5. Okay, now we're gonna mix letters and numbers. I want you to break up 128. Now, I don't know what 128 is, so this is what I'm gonna do. I make my little cube root, and I start here, 128. I know it's an even number, so I can cut it in half. 2 goes into 128 how many times? 64. And I know 64 is 8 times 8. And once I hit 8, I know 8 has 3 twos.
So,
Okay, so
7
you got it. Say it again.
2, 7 2.
7 twos. 1, 2, 3, 4, 5, 6, 7. How many X's do we have? 1, 2, 3, 4, 5, 6, 7. Now this is a visual for you guys. Are you gonna have to do this for all of them? No. But I want you to understand what's going on here. How many of a kind are we looking for?
3 of a kind.
So there's 3 twos. Here's another 3 twos. How about the X's? There's 3 X's. Here's 3 X's. So what's coming out of that radical?
2 others.
2x,
4x squared.
4x squared, you got it. 4x squared comes out.
Wait, is there a different way to break the?
Yeah,
The 2
yeah.
twos come out.
I'll show you in a minute.
Okay.
I'm gonna show them the shortcut in a minute. But I want them to see this part. Okay, so 128 consists of 7 twos, and we have 7 X's here. We're looking for 3 of a kind. So there's 2 sets of 3 twos. It's hard to say that. 2 sets of 3 twos. So 2 times 2 is 4, and 2 sets of X's, so X squared. Everyone with me? These are out. They're out of that radical. Did everything come out?
No.
No. What stayed?
2x.
So plus 2
So what you have to do is keep the index cube root, and this is what stays. Unfortunately, it says, what is the simplest form of this? This is your simpler, it doesn't look simpler to me, it looks more complicated, but this, needless to say, is your simplest form. Sometimes the simplest form doesn't look the simplest. I think that looks simpler. But this is the simplest form, is when you can take everything out of the radical. Now there's another way you could have done this problem. I want you to look at this cube root of x to the 7th, that part. How do you rewrite this in rational form, like we did in the previous problems? X to the what power? 7/3. Can you change 7/3 to a mixed number, like you did in 3rd, 4th grade? What is 7/3 equal to? 2
1/3.
and a third. 2 and a third. So x to the 2 and 1/3 power. So I want you to look at this answer here and see if you can compare where the x squared came from outside. Can someone give me a comparison here? Where's the x squared? And then look at this. What is it?
Wait, I was gonna ask something. Can't you multiply the 3 on the outside and get like x to the 6, and then you do it that way? That's how it was.
X to the 6.
You get like x to the 6.
Wait, this
and
3,
then-
you're gonna multiply it?
Yeah, you're
No, no, no.
gonna see how many times it goes into the 7, and it goes in there twice.
No, you would write this as 2, the base is 2, how many 2s do you have? 7/3. You are not multiplying this 3.
I mean, I
by
got
anything.
the same answer as you, I did it different.
Well, it might be a coincidence, but you don't multiply this 3 by anything.
No, you just see how many times it goes into the.
Yeah, that's what we just did.
Yeah, and it goes in there twice.
Yep. Now, see this 1/3? That means there's 1x left in its cube root. 1x left, so 1x left in cube root. The 2 are the whole number of x's that came out, and this is the answer right here. Okay, flip over. Let's try number 4 together. Okay, anyone have a suggestion what to do? First of all, can we do this problem? Yes, we can do it. Anyone? What is 6 times negative 9?
Negative.
Mhm. And how many x's do we have? We have 2 here and we have 3 here. How many total? 5. Okay, I need to break negative 54 up into what? Negative
27
1
and 2.
times 2 times 3 times 3 times 3. And then we have 5 x's. 1, 2, 3, 4, 5. This is the visual. If you're a visual person, you may need to do this. If you can do the shortcut, then go for it. So what's gonna come out? I know that, see this 3? We're looking for 3 of a kind, right? So group up 3 of a kind. What comes out? That. Anything else? X. There's one more little thing here, but I didn't write it out. What times what is negative 1? Negative 1. You actually have 3 negative 1s here. I didn't write it out. Does everyone understand that? So you have a negative 1. That's 3. I just didn't write it out. You have a negative 1, a positive 3, and an x. So what comes out?
Negative 3x.
And what stays?
2x squared.
You got it. Okay, let's try 5.
Wait, could you go back? Did you
Yeah.
keep the squared? Or
Say it again.
would you do, because it was x cubed, what did you do with that?
You add these x, if bases are the same, you have 5 x's here. 1, 2, 3, 4, 5. You have 5 x's.
Alright.
2 under here and 3 under here. You have a total of 5. But 3 of them will cause it to come out, so there's the 3. This is gone. These 2 stay. Okay, 5. Now, I like to leave it in pieces. I'll leave it in pieces. How does 48 break up? 6 times 8 is 48. And I know 6 is 2 times 3, and this is 2, 2, 2. That's how my brain does that. I go 6 times 8 is 48. And then 50, in my head, I think of 50 is 2 times 25. Does that make sense? Now, can I do this problem? I should have thought about that first. Can I do this problem?
Yep.
Yes, the indexes are the same, I can. What am I looking for? How many of a kind? 2. What comes out? 2 2s, anything else? And a 5. So I'm gonna take out these 2s, that's a 2, another 2, and a 5. What's 2 times 2? 4, 4 times 5 is 20. What stays?
2 and 3.
What is 2 and 3? Good.
Where'd you get 20 from?
Where'd I get what?
20 from?
20. 2 times 2. Here's one set of 2s. Here's another set of 2s. And a set of 5s. 2 times 2 is 4, times 5 is 20.
Oh.
Okay? And the 6 comes from these 2 that were not paired. All right, now, how many x's, now let's go to the x's. How many x's do you have? 7. This is what you have. You have x to the 7 halves power. How do you convert 7 halves to a mixed number? 3 and 1/2. So, how many full x's come out? 3. How many stay? 1. Now let's do the y's.
What happens to the 1/2? It just doesn't happen.
It's the square root, x to the 1/2,
okay.
that's what that is. And how many y's do you have? You have 2 here and 4 here. You have y to the 6th power. 6 over 2, which is what? 3. Is there any left over?
No.
And there you go, that's your answer. Now, if you didn't understand the short way, the fractional way, you should, but if you need to write it all out, like I did here, then go for it. Whatever it takes, do that. So this answer should be 20x cubed y cubed, the square root of 6x. Okay, and let's do 6. Number 6. Can someone tell me what the index is on this? It's a 4. What's up with this 2 and this 4 right here? Huh? What do you want to do with them?
Each times them, right?
You're gonna times them. So 2 times 4 is 8. So you have 8 standing outside here. Now we've got the 4th root. I'm gonna break 12 up. How does 12 break up?
2 and 3.
And how does 27 break up?
3, 3.
So here's something else you can do. What did I do?
Just put them together.
Put them together, because they can, because they're both, the indexes are the same. So 12 is 2 times 2 times 3, and 27 is 3 times 3 times 3.
Each got 1.
How many x's, do I have too many? No, that's right, that's right. Oh, you just have 1, 3, you said,
That's what I-
yeah. How many x's do we have? 9. 1, 2, I'm gonna write it out for those of you that are visual. 4, 5, 6, 7, 8, 9. How many y's do you have? 1, 2, 3, 4, 5, 6. So how many of a kind am I looking for?
4.
Okay, and we already heard someone say we have 4 threes. What else do you have 4 of?
Where it says
Um,
analyze.
Okay, so what comes out? And what do I do with this 8? Add it in? What do you mean by add it in? So is 11?
Yeah.
No.
We're multiplying. So what's the number in front here?
24.
Good, 24. So that's taken care of. What else? 2 x's or x squared? And how about y? Okay, what's left over? 4. You got it. Sorry, I didn't mean to. It's 24x squared y, 4th root of 4xy squared.
It's so confusing,
Okay, last one is this problem 3. Everyone's gonna do this on their own. If you wanna break it up,